Okay, hi. So today I'll introduce to you algebraic representation of our vector on the vector series vectors for down, right? So just the topic named it's a vector for down. Okay, and it is your algebraic representation of a vector because the last lectures, the 1 to 6, okay, I had introduced the geometrical representations of vectors like that, and now I'll introduce to you algebraic representations of vector. Okay, so it is your next part 7 lecture is algebraic representation of vector, algebraic representation, right? Okay, so first of all there a subtopic, actually it's a unit vectors, right? So unit vectors, so what is the unit vector actually? Unit vectors, so the meaning of unit vector actually, right? So all of you know the meaning of unit, right? Unit means one, okay, is a unit, right? One. So unit means one. First of all, unit means one. Okay. All of you know here. So unit means one, right? So obviously, as the name suggests, the unit vector means a vector which has magnitude just one unit, right? A one unit, which is the magnitude is the one unit, right? It may be 1 centimeter, it may be 1 millimeter, maybe 1 kilometer. It's just a unit, okay? Okay, so a vector which has the magnitude 1 unit. Okay, so is the unit vector the vector which has the magnitude only 1 unit, and plus as well as the direction. Obviously it's a vector plus it's a specific direction, right? It's a specific direction. Okay. Okay. So first of all, according to a syllabus for your boards or G or NEET, somehow there are three types of unit vector here. Named I had, right? The unit vector actually goes the I, some there is specifically I had. It's a hat, or you can call cap, right? It's a I had. Just named it I had. Oh, I had or I cap. It's your choice. Call this vector I had or I cap. Similarly, the J hat or J cap, J hat or J cap, and the K, right? Is the K cap or the K hat or the K cap, right? You can call anything I hat or I cap, I hat or I mean J hat or J cap, and the K hat or K cap, right? Is the three fundamental unit vectors here. Just a specified names I hat, J hat, and K hat. Okay. Okay. So according to syllabus, it is a three fundamental unit vector here: I hat, j hat, or this k hat. Okay. Okay. So I think all of you know the axis, right? There are three axes in a three-dimensional space. Okay. There's the x, y, and z. Right? So these are, I just draw a coordinate system here. It's the x, it's the y, and it is the z, because the z means it's a perpendicular. Both the axes, actually x and y, is actually 90 degree each other, and obviously our z is obviously 90 degree to both x and y, like this. This is the z. Okay. Because it is the z axis, it is actually a 90 degree with x axis, and obviously the 90 degree with y axis, right? Okay. It is a z axis, but I couldn't draw this z axis in this two-dimensional board, right? It's a three-dimensional plane. Okay, just it is a z axis like this thing. Okay. Okay. Just for simplicity, take this x and y here. Okay. Okay. So I had or I kept means, okay, just erase this thing. So I had or I kept means the unit vector along positive x axis, j cap or j hat means unit vector along positive y axis, and the k hat or k cap means the unit vector along positive z axis, right? Okay. So it is our three types of fundamental unit vector here. It's the I hat or I cap, j hat or j cap, and the k hat or k cap. Here is this. Okay. Okay. Now to clarify this thing, okay, so just draw a coordinate system here. First of all, okay, just erase something here. Okay, just I erase something here, and just rewrite this thing. Unit vector means, first of all, just start point here. The unit vector means, that means a vector having magnitude 1 unit, first of all, and here is the two types. I just take for simplicity the two types here. One is the I cap or I hat, the unit vector along x axis, and here the j hat, the unit vector along y axis. Okay. So now the clarification of this thing, just draw a coordinate system here. Okay, just draw a coordinate system here. So please draw a coordinate system here. Is there your coordinate system? All of you know how to draw a coordinate system. It is your x, it is your y. Okay, so it is actually positive x, right? Just write it positive x, it is your positive y, it is your negative x, it is your negative y, right? And obviously all of you know the scaling, right? All of you know how to scale the graph, and how to scale the axis, right? So it is the origin. All of you know it is the origin. It is actually 0, 0. It is the 1, right? It is a 2 here. It is a 3 here. it's a 4 here, it's a 5, it's a 6, and so many. It is a 1, it is a 2, it is a 3, it is a 4, it is a 5. It is actually your -1, it is your -2, it is your -3, it is your -4, it is your -5 here. And then similarly, it is a -1, it is a -2, it is a -3, it is a -4. And the so many here. Okay. Now, what is the I cap, right? Okay, just look at this stuff very carefully. Use your graph paper and I just scale it. Just scale it here. 1, 2, 3, 4, 5, 6 here. 1, 2, 3, 4, 5, 6, and then -1, -2, -3, -4, -5. And it is down here. -1, -2, -3, -4. Okay. And obviously, all of you know, here is 0, it's a 1, right? Just a one step here. That means the length of this thing actually the 1, right? Length of this thing actually 1. And obviously the I hat means the unit vector along positive x-axis, and the j hat means unit vector along the positive y-axis, right? And what is a unit vector? A vector having magnitude 1 unit, right? So obviously you can write this thing actually is a 1 unit, right? Because it's a one step here, 0 to 1, and it's a positive x-axis, right? So you can write it is actually your I hat. Right? It is actually your I hat, because I hat means the unit vector along positive x-axis. So here is the positive x-axis, and the unit vector means a vector having the magnitude 1 unit. So obviously this is a 1 unit, right? Because 0 to 1 means the length of this piece actually 1. Okay, so 1 unit. So you can call this thing actually I hat or I cap. Okay. Similarly, it is obviously I cap, because 1 to 2 obviously 1 unit, and along the positive x, so it is your I cap. Obviously, from 2 to 3, it is actually 1 unit. The one step here from 2 to 3, it is a positive x-axis, so you can call it I hat here, right? And the 3 to 4, it is obviously 1 unit, because the 3 to 4, just one step here, the positive x-axis is I cap here. Okay, just it is I cap, it is I cap, it is I cap, it is I cap. Okay? And all of you know, I cap plus I cap, what will happen? It is very simple, 2 I cap, right? It's I cap plus I cap means 2 I cap. So obviously, here is the I cap and here is the I cap. So obviously, if you add this I cap plus I cap, that means it is actually your 2 I cap, right? Okay, it is I cap plus I cap here. So I cap plus I cap means 2 I cap. And if it is a 2 I cap and it is a I cap, just draw here I cap. So 2 I cap plus I cap. What will this thing? It is a 3 I cap. So it is a 3 I cap, right? It is a 3 I cap. It is I cap. So obviously it is a your 4 I cap, right? It's very interesting, right? It is a 4 I cap. From here to there is a 5 I cap. From here to there is a 6 I cap. Okay. Similarly, according to your y-axis, the j hat means unit vector along the positive y-axis. So obviously it is a unit, I mean from one step from 0 to 1, right? 0 to 1, just go to one step. Because it is a one step here, and obviously it is a positive y-axis, so it is your j cap, right? This is j cap. Obviously, because j cap means a unit vector along the positive y-axis, and a unit vector means a vector having a magnitude 1 unit. So obviously it is a 1 unit, right? From 0 to 1 it is a 1 unit, and along the positive y direction. So it is j cap, and it is also j cap because 1 to 2 to 1 step here j cap. Here is another j cap because 2 to 3 is another j cap. 1 step here. 3 to 4 is another j cap here. Right? So obviously, similarly, j cap plus j cap, that means 2 j cap. Right? Very simple case. So obviously, just add j cap plus j cap. So obviously, it is the 2 j cap, right? It is your 2 j cap, and the 2 j cap plus j cap, it is your 3 j cap, right? It is a 3 j cap. So it is a 3 j cap, and so many here. It is a 4 j cap here. It is a 5 j cap here, and so many. Okay, it's a 5 j cap. Okay, this is very simple thing, right? J cap plus j cap means 2 j cap. This is a 2 j cap, and the 2 j cap plus j cap means 3 j cap. It is a 3 j cap. The 3 j cap plus j cap means 4 j cap. It is a 4 j cap. 4 j cap plus j cap means 5 j cap. So obviously it is a 5 j cap. Okay. Okay. So now erase this thing from here. Okay. Okay, so now I'll introduce what will be the minus I cap and minus j cap, right? Minus I cap and minus j cap. Okay, so all of you know the concept of opposite vector, right? Opposite vector means the vector having the same magnitude but opposite in direction, right? The vectors having same magnitude but opposite in direction. So if it is your I cap, so obviously it is your minus I cap, right? Because the length is the same and the magnitude of these two vectors is same, but the direction is just opposite. So if it is your I cap, so obviously it is your minus I cap. It's a very simple thing because direction is just opposite. And if you shift this thing from here to there actually, okay, so it is your minus I cap, right? Because this is actually negative y-axis. So it is your minus I cap. It is another minus I cap here. It is another minus I cap here. And obviously, the minus I cap means minus 2 I cap, right? So ultimately, it is actually a minus I cap. It is actually minus I cap. So ultimately, from here, it is your minus 2 I cap, right? It is actually your minus 2 I cap. It is actually your minus I cap. So ultimately, minus 2 I cap minus I cap, it is your minus 3 I cap. So obviously it is your minus 3 I cap. Right? The similar thing will happen in that negative y-axis. Okay, just erase this thing. It is your minus I cap, it is a minus I cap, it is a minus I cap. So obviously from here to there it is a minus 2 I cap, from here to there it is a minus 3 I cap, and so many. From here to there it is a minus 4 I cap, from here to there it is a minus 5 I cap, so many. Okay, and a similar thing will happen if you consider the minus j cap, right? because similarly the j cap means, obviously j cap means the negative y axis. So it is your minus j cap here, it is another minus j cap here. So the minus j cap with minus j cap means it is your minus 2 j cap, right? And obviously it is minus 2 j cap, it is a minus j cap. So obviously this vector actually minus 3 j cap, and so many is a minus 3 j cap, so it's a minus 4 j cap, so many here, right? Okay, so now I'll introduce to you the addition and subtraction rule from the algebraic representation. Right? It's a very interesting. Okay, addition and subtraction rule from our algebraic representation, because I already introduced this thing in our geometrical representation. Now it is our turn to represent addition and subtraction from this geometrical representation, from this algebraic representation. Okay, so if I want to calculate 2I cap plus 4j cap, what will be this thing? Just first draw what will be the value of, what will be the vector of 2I cap. Obviously it is your 2I cap, right? Just erase this thing. So it is your 2I cap, right? Just name it 2I cap from here to there, right? It is a 2I cap, very simple. And it is a 4j cap. Obviously j cap plus j cap plus j cap plus j cap, it is your 4j cap. Now I want to add 2I cap plus 4j cap. Here is a 2I cap, here is a 4j cap. Just want to add this thing. So obviously all of you know how to add these two vectors from our geometrical sense. Obviously just translate this vector from here to there. It is a similar, just a parallel transformation. It is a 4j cap and it is a new 4j cap. It is a put a dot here and just connect here. It is your 2I cap plus 4j cap, right? 2I cap plus 4j cap. Okay. Now I will want to calculate what will be the minus 2I cap plus 3j cap. So obviously just draw what will be the minus 2I cap, right? So the minus 2I cap means here it is your minus 2I cap, right? Minus 2I cap, because there is a minus I cap with minus I cap, so ultimately it is a minus 2I cap. And what is the 3j cap? It is, right? J cap, j cap, j cap. It is your 3j cap, right? 3j cap. And obviously just addition is a minus 2I cap plus 3j cap. That means add these two vectors here and here. Please add. And obviously all of you know how to add. Just translate this thing from here to there. Parallel transformation. Okay. It is your new minus 3j cap. And obviously put a dot here and connect these two dots. Right. So it is your minus 2I cap plus 3j cap. No problem. Okay. And what will be the minus 4I cap minus just take it 2j cap. Okay. So minus 4I cap means obviously from here it is a 4 unit there. So obviously it is your minus 4I cap. Okay. So from here to there it is a minus 4I cap. And the minus 2j cap means here it is your minus 2j cap, right? And just add this thing because it is actually here. All of you know the plus minus product of plus and minus goes to minus. just add with the minus 4 I cap with the minus 2 j cap, just add it. I mean it's a minus 4 I cap, it's a minus 2 j cap. Just add this thing and all of you know how to add. It is just to shift from here to there. Okay, it is your minus 2 j cap and just dot it here, connect these two dots. So obviously this is a minus 2 j cap with a minus 4 I cap. Okay, so it is our addition or subtraction of two vectors in our algebraic representation, right? This is very simple. It's very simple. Okay. 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 So I just introduced here the addition rule and subtraction rule of vectors in our algebraic representation, and okay, then I'll today obviously okay, just leave it. I just in the next class I will introduce to you the resolution of vectors, how to break the components of vector and the product of vector, right? Okay, so it is just a end of our class. Okay.